Now we are going to discuss numericals on the basis of lens maker formula in Rayoptics. A diverging lens of refractive index refractive index 1.5 and focal length 15 centimeters in air has same radii of curvature. Radius of curvature for both sides. For both sides. If it is immersed in a liquid of refractive index refractive index 1.7. Calculate focal length of the lens in liquid given. Dear students, once again read the question carefully. A diverging lens of refractive index 1.5 and focal length 15 centimeters in air over has same radius of curvature, that means 15 centimeters radius of curvature for both sides. If it is immersed in a liquid of refractive index 1.7, calculate focal length of the lens in liquid. This is the question. First, try to understand what are the important terms in this question. A diverging lens. What is the diverging lens? This is called diverging lens. This is called diverging lens means what we can call it as? It also we called as concave lens. Okay, beta? So, diverging lens, another name is concave lens. That is the point you have to remember. And it's a refractive index. It's a refractive index. How much? 1.5. It's a refractive index. How much? 1.5. Okay, super. Now, focal length is 15 centimeters in air. Now, where it is in the air? What is the focal length? 15 centimeters. Okay, Sabash. Has same radius of curvature for both sides. That means from here to here, radius of curvature. From here to here, radius of curvature. Both are same. Okay? And we know that F is equal R by 2. Now tell me, what is the focal length of this one? Obviously, that means here F is equal, how much? Given by examiner, 15 centimeters. Okay? That means what is R? R is equal to F. Okay? That means R is equal 2 into what is F? 15. Therefore, R is equal 30 centimeters. Now the same lens is immersed in a liquid. That means take a liquid here. Take a liquid. Okay. It's a refractive index 1.7. Now our concave lens is here. What is its refractive index? 1.5. This liquid refractive index is 1.7. Now calculate focal length of the lens. Previously, what is the focal length? 15 centimeters. Now, at present, what is the focal length? Question mark. This is the examiner want. Okay? That means whatever data at present I displayed here, you have to imagine in the examination hall. Now, I am going to solve slowly. Please observe carefully. Now, solution. Mu is equal to 1.5. F is equal to 15 centimeters. Remember, for convex, where is the focal length? The focal length is here only. Therefore, what is F? Minus. Okay? F is equal to minus. R1 is equal to minus R. R2 is equal to plus R. That means from here, this is radius of curvature. At the same time, This is also radius of curvature. For this one, radius of curvature is called R2. For this one, radius of curvature is called R1. So for this one, radius of curvature is called R1. So it gives minus. For this one, gives plus. Okay. Now formula 1 by f is equal to mu minus 1 into 1 by R1 minus 1 by R2. 1 by minus 15 is equal to 1.5 minus 1 into 1 by, what is R1? Minus R. Minus R minus 1 by, what is R2? Plus R. Okay. Therefore, 1 by minus 15 is equal to how much? 0.5 into, here minus 1 by R plus into minus, minus 1 by R, that is called 1 by minus 15 is equal to 1 by 2. I wrote 0.5 as 1 by 2 into, what is the LCM? R. Here how much? Minus 1 minus 1. Therefore, minus 1 by 15 is equal to minus 1 by R. Therefore, R is equal to 15 centimeters. Okay. When the concave lens of refractive index mu is equal to 1.5 in air, okay, in air of focal length 15 centimeters. Now, one part completed. What is the second part? Now, take a liquid. Now, I kept a convex lens inside the liquid. Now, the liquid refractive index is 1.7. Here is 1.5 air. In this case, what is the focal length of this one? What is the focal length of this one? This is the question. Now, go for discussion. Let F dash be the focal length of lens in liquid. Okay, imagine it is F dash. Okay, now we know that 1 by F dash is equal to, what is the formula? Refractive index of glass by refractive index of liquid minus 1 into 1 by R1 minus 1 by R2. Okay? That means we can write 1 by F dash is equal to 1.5 by 1.7 minus 1 into 1 by R1 minus 1 by R2, that is equal 1.5 by 1.7 minus 1 into 1 by minus 15 minus 1 by plus 15. I already told how, because it is a convex lens, concave lens. Here is R2 taken as plus here is R1. R1 taken as minus. R1 taken as minus. Okay? Therefore, that is equal how much? 0.2 by 1.7 minus into how much? Minus 2 by 15. That is equal how much? 0.4 whole by how much? 1.7 into 15. Okay? What is this one? 1 by f dash. Okay? That means what is f dash? F dash is equal 1.7 into 15 whole by 0.4. How much? That is equal 63.75 centimeters. Okay? Now, what we understood from this one? Initially, it is concave lens. It is concave lens. Focal length is equal to how much? Minus 15 centimeters. Whenever we immersed in a liquid, what is the focal length? 63.75. That means the rays falls on it, acts like as a converging lens. ऐसा आकर क्या होता है? Like this. Like this. Why? Because you got plus. That means it becomes as a converging lens. Whenever a concave lens immersed in a refractive index of high liquid, high refractive index liquid, so it will act like as a converging lens. Okay? That is the point we have to remember. One time, this question raised by the CBSE examiner. Whenever a concave lens immersed in a high refractive index liquid, what will be happen? Its refractive index is 1.5. Okay? But the liquid is 1.7. What will happen? Converging. Okay? Please remember that point. However, our answer over here. This is just a concept I told for you to make you understand. However, I can write also. Please listen. That means the diverging lens. Diverging lens means concave lens. Concave lens behave as converging lens. Converging lens. Converging lens means convex lens. That means a concave lens immersed in a high refractive index of a liquid, immediately concave lens act like as a convex lens. Okay, that is the meaning. Lens in the liquid. That means a concave lens it is a diverging lens slash concave lens immersed in a its refractive index is 1.5. Its refractive index is 1.7. Immersed in a high refractive index of a liquid, it will be act like as a converging lens slash convex lens. Okay, convex lens convex lens or convex lens. Please, this is the conceptual. However, I hope you understood this video. Thank you.